At 11:03 in the morning on April 17, 2018, Southwest Airlines Flight 1380 was climbing out of New York toward Dallas. The Boeing 737 had been in the air for 12 minutes. 144 passengers and 5 crew members were on board, heading into what felt like an ordinary Tuesday. At 32,000 feet, the aircraft's left engine suddenly fractured. What happened next would kill one person, nearly kill another, and expose a dangerous blind spot in how the world certifies aircraft engines safe. Inside the CFM56-7B engine on the left wing, fan blade number 13 had been carrying a hidden fracture since around 2012. The fatigue crack ran through the dovetail, the root of the blade where it locks into the engine disc. It was microscopic at first, maybe 2 millimeters deep, but with every flight, every vibration, every thermal cycle, the crack grew. 6 years of undetected growth. 6 years of commercial flights with an engine that was quietly failing from the inside. The crack reached its limit during the climb through 32,000 feet. The blade snapped. It spun into the engine case at tremendous speed and shattered into fragments. Some pieces shot forward into the inlet. Others were absorbed by the containment case, part of the engine's design to stop released debris from escaping the nacelle. But the impact was so violent that it tore through the radial restraint fitting, the structural joint that holds the fan cowl to the engine. The cowl itself began to fail. A piece of the fan cowl, roughly the size of a briefcase, tore free from the engine. It traveled forward, struck the left side of the fuselage near row 14, and hit the window. The window shattered. Explosive decompression began. The cabin filled with roaring wind and pressure loss. Jennifer Riordan, a 43-year-old mother of 2 and an executive at Wells Fargo, was sitting in row 14. The force of the decompression pulled her partially out of the aircraft. She was fatally injured. The flight deck crew acted with precision. Captain Tammy Jo Schultz, a former Navy fighter pilot with more than 11,000 hours in the 737, immediately recognized the emergency. She declared a mayday, performed an emergency descent, and diverted the aircraft to Philadelphia International Airport 17 minutes away. The crew had to manage a damaged engine, an open cabin, a depressurized section, and a catastrophic structural failure, while keeping an aircraft with 148 other people on board stable enough to land. They succeeded. The NTSB investigation began immediately. What they found was astonishing. The fatigue crack had been present for nearly 6 years, growing silently through the 2012 overhaul and inspection. The blade had been shot-peened, a surface hardening treatment meant to prevent cracks. But over time, the compressive stress from the peening had relaxed. The blade root became more susceptible to fatigue. Each flight added micro-damage. The crack started small. It grew in complete silence. The real shock came when the NTSB examined how the engine case had been certified. When CFM56-7B engines were tested before certification, they were subjected to controlled blade release scenarios. But those tests did not account for the way this blade actually failed. The separation mechanics were different. The impact point was different. The displacement wave the fracturing blade created was not something the 737's fuselage had been engineered to absorb. The certification process had a gap, a critical gap that no one had recognized until now. The FAA and EASA issued emergency airworthiness directives within weeks. Every CFM56-7B engine with significant flight hours was to be inspected using ultrasonic testing and eddy current detection, methods sensitive enough to find cracks no human eye could see. Initial inspections had to be completed in 20 days for high-cycle engines, then repetitive inspections every 3,000 flight cycles. Later, blade root lubrication intervals were cut in half to keep friction and fatigue stresses lower. The industry moved fast. The NTSB issued 7 safety recommendations. Boeing was ordered to redesign the 737 fan cowl to withstand a blade-out event better. New aircraft would be built with the redesigned structure. The entire in-service fleet would be retrofitted. All of this traced back to one fatigue crack that had grown unnoticed through 6 years of flight. One crack that was finally caught only because it had fractured catastrophically and nearly killed an entire airplane full of people. The aircraft that experienced the failure registration N772SW, never returned to scheduled service. It was flown to Everett for repairs, then moved to long-term storage at Victorville, California, where it remains. Jennifer Riordan's death was the first fatality on a U.S. commercial flight in 9 years. Her death, and the investigation that followed, became the reason thousands of fan blades were inspected, redesigned, specifications were drafted, and containment engineering was understood more deeply than it had been before. One crack, caught too late, changed everything.